Hi everyone, I am Prakash. This is Scholar Department of Electrical Engineering, Iavg. I am here to take an assignment session of the course Control and Tuning Method in Switch Mode Power Converter. So, this course taught by the Professor Santanu Professor, Department of Electrical Engineering, IIT Kharagpur. I am here to take only the assignment session. Okay, let's start the session. Question. I have taken the question a simple electric circuit and find the efficiency of the following circuit converter. So, and here the simple electrical circuit, a simple voltage source and connecting the two resistance in series, 5 kilo ohm and 10 kilo ohm. This one is 5 kilo ohm actually, and this one 10 kilo ohm. You know about the finding the efficiency. Efficiency is the output power divided by input power. You can also written as the output power divided by output power plus losses. If you include the losses in output power, then it is the input power. And you can also written as the input power minus losses. When you the subtract of losses in the input power, then find the output power and input power. In this circuit, we find the power, output power. Output power means output voltage into output current and P output. And input power is the input voltage and input current. Here is the input current is the same as the output current because of series connected circuit. Then you can written as the input power is equal to V in input voltage into output current, because the output current is equal to input current in the circuit. First we find the output voltage. The output voltage you can apply the voltage divider rules in the series electrical circuit. Then you find the voltage divider is the resistance. So here you find the voltage is 10 kilo ohm and divided by total series resistance 5 plus 10 kilo ohm. And this is kilo ohm cancel out into VA is equal to 0.667 into VA. Then efficiency is equal to P output divided by P input. P output is equal to V output into I output, and V input into I output. You cancel out. V output is equal to 0.667 V in and divided by V in, cancel out. Efficiency is equal to 66.67%. If you convert this into percentage, then you find this only 66%. The option also given to you in the assignment. I have taken second question. Second question, RLC series circuit. In RLC series circuit, you find the current equation, differential equation of the current in the circuit. If you find the current, then you is a simple electrical AC circuit. Like we applied the KVL in the loop. This is IET is given. 2 microfarad is the capacitor, 6 Henry is inductor, and 4 ohm resistance. First, what do you know about the sign? If the current passes through entirely through negative sign, if any element, then that element is known as the source element. This one is current enter in as negative terminal, then this is the source. And when the current enter in the passive element, here the passive element is the resistance, inductor and capacitor, the passive element, then current enter is the positive terminals. This one is positive. Well, positive, here positive enter, which means current enter, it means this element is the passive element. And where the current enter is the negative terminal, then it is the active source. If the sign is defined, then simply apply the KVL rule. When you apply the KVL rule, first you take only one sign. It means if you take the before the first sign, then you take every one first sign. If you take the second sign for the element sign, then you take a second sign of the same all of the element. Then you apply the KVL rules. This is the minus 2 sin t and plus 4 ohm resistance into IR. Inductor, we know about the inductor, L di upon dt is the voltage. Then we should take L is equal to 6 dit divided by dt. In capacitor, you know about the capacitor, integration of I in dt is equal to Vc. And apply here Vc is equal to 1 by C, C is equal to 2 farad, integration of I to dt is equal to dt. KVL says that some algebraic sum of all voltages is the 0. And 0, you can rearrange this one. Then 6 dit by dt plus 4 it plus half it dt is equal to 2 sin t. You change the integral sign here, then you apply it once again the differential, and it means differentiate the equation once again. Then you find 6 d2it divided by dt2 plus 4 dit divided by dt. Here the integral sign is remove and simply it divided by half is and sign, differentiate the sine signal, then you find a cosine signal. You multiply it to 2 and go all of segment, then you find 12 d2it divided by dt square 8 dit by dt plus it is equal to 4 cos t. Is the current differential equation. In the circuit, we have seen the second of the option, the correct option. For that, I take the third question. Third question is the voltage across the switch and current through the semiconductor switches is given. Voltage, this is one the voltage. This is the current waveform, and this is the voltage waveform. This is the current waveform, and this one voltage waveform. Voltage across the switches is given, and current through the switches. When switch is on, then current flow. This is not an ideal switches. That's why is a minimum 2 voltage the drop across the switches is given here. First, to find in this question, you find the power loss. Power loss means it means power losses. How much power losses in the circuit when it is on. First of all, you should know about the power calculation in any circuit. If you know the power calculation, you will also know about the voltage and current. Okay, this is okay. That is one formula also, I square into R, and second one is V square divided by R. So three formula you have to find the power. But in this question, what is the current and voltage you take? Is the average value or RMS value? This one is the important thing. So current is okay. If the current is a constant current, then it's okay. But if the current in the this type of waveform, then it will not take the same as you can average RMS. You should know about the what you take. First of all, I take a waveform like that, the triangular waveform. I take a current 0, t, 2t, 3t. This is the time period of this waveform. This one is take a 3 ampere. This is example. And suppose that you have one resistance, which resistance is current is flowing through the resistor. Then what you take? What will you take? You take average current or RMS current of this waveform. This one is an important thing. I explain both. If you take average of this thing, then I average of this waveform, you should know about the triangle. This one area of the triangle is the average divided by time period. And you have area of triangle, you know half, and the height of 3 ampere into width 3 divided by total time period is the average. And t is to cancel out, 3 by 2 is equal to 1.5 ampere. Average current. But you find this RMS current. When you find this from RMS current, so then if you know that this one is the in triangular wave, you divide by the root 3 is the RMS current of this waveform. Then this one is your root 3 value is 1.732 ampere. This one difference occurs in the circuit. You see that this is not equal. It's all different. Average current is 1.5 ampere and RMS current 1.732 ampere current. Then what you should do? What you will take? Average current will take or RMS current will take? This is a important thing. Because the both are not same. If you see about the DC current, then this current is the same as the average, and RMS is the same of this. You can find it. In AC signal analysis, AC sinusoidal wave, you take RMS of this thing. But here the not a sinusoidal signal, not a pure DC signal. Then what will you take? First of all, you should know about the what take. First, I think I calculate the power. Power is equal to the universal formula 1 by t 0 to t v into I into dt. This one is the formula of calculating the power. This is applied to every signal. T is the time period. But when you see this first thing, only resistance passing through the current passing through the constant resistance, then you find the voltage across this. Voltage across this is equal to I into R. You take there 1 by T divided by 0 to T. Replace the voltage I into R into I dt 1 by T 0 to T I square into R into dt. R is a constant. You take outside 0 to T I square into dt. Taking the bracket 0 to T I square into dt. Here the power is. You know about that? This one is the RMS current. Use no RMS formula, RMS current. RMS means root mean square. Root mean means averages square I square. You take a current. If you square up this equation, I square RMS is equal to 1 by T integration of 0 to T I square into dt. This one is the same as, it means you can replace this R into I RMS square. In this condition, you will take the RMS value of this waveform. But second thing, we have also a resistance across. You apply this voltage waveform, same as you also V square by R is the power. It means this voltage also is the RMS value you should take. I'm not discuss about the more about that, because of same as the current I square current with the V square voltage, the RMS voltage. But the third thing, if you see that your voltage source, constant voltage source V passing a current same this current in a constant voltage, then what you will take, the RMS current or average current is a different. Same thing, apply formula, power is equal to 1 by time period divided by 0 to time period V into Y to dt. Here V is a constant and V outside 0 to T I into dt. If V outside 1 by T I into dt. You know about the formula? This formula is the average current formula. This one the average current. It means if you calculated the power across the constant voltage, then you apply the average current of that. Means average current means voltage, constant voltage in our I averages. This question given in the your question assignment. This is the correct waveform. This one is the voltage waveform. This is the constant voltage. Here the constant voltage applied, when constant voltage applied any current across that, then you should take the average current of that. Then you can find averages of this current. First we divide into third part A, B, C. You can find a direct value of that. I'm not to go too much in this. This one, find area of A is equal to area of triangle A, total average I average is equal to area of triangle A plus area of rectangle B plus area of triangle C. Area of A, you know about the half into height 20 into base 2 microsecond plus 20 into 4 microsecond plus same half into 20 into 2 is equal to divided by average. You find, then divided by total time period is the area only. If you want to average means area of that into total time period. Total time period is 12 microsecond. Here not the power losses is not here between 8 microsecond to 12 microsecond because of the current is 0. If the current is 0, the P into I 0 means power 0, then power collected between the 0 to 8 microsecond only. 8 microsecond I find it. 2 cancel out, 2 cancel out, 20 20 40, 24 ja 80, 80 plus 20 120 divided by 12 is equal to 10 watt. This is not a 20 watt, this is 10 watt power of the power of this. Okay, the second question, third question completed. Here is the fourth question. Here find the efficiency of the converter configuration on. Here the not a ideal converter. Here the switch on resistance also given, and inductor resistance is also given. Then it is not an ideal. On resistance, you see that this one is on resistance or on. When the switch is on, then some resistance behave like a resistance of MOSFET. Here is a MOSFET switches. And then inductor also have some resistance. Then this one is RL, inductor resistance. Have a circuit. And the duty ratio is the 0 to dt. This means the D is the duty ratio, and dt times is on period, and t minus dt, it means 1 minus d into t time is the off period. On period dt and minus d time on period, off period. You find the efficiency. Efficiency is same as I given up above first question. Efficiency is output power divided by input power, same as here. But first of all, we find the output power, output voltage. If you find output voltage, then you can input voltage. If you here the find output voltage in terms of input voltage. If is this one is the circuit is the buck converter. If you see about the circuit is the buck converter. In ideal buck converter, you know about the output equal to dVs, yeah, V in. This one is the output voltage we have found. The sorry, output voltage equation. But here the lossless inductor and switch turn on resistance also given. Then this one is not valid further. Some extra term added in this. Then I want to find it. First of all, draw the circuit and switch is on. When switch is on, then what you see there. If switch is on, then this one is connected to this, and voltage across that positive connected to the here positive voltage, negative here diode is via reverse bias, and this one circuit is completed from this one to this one. In this period, the inductor will get charged and output voltage fine. And after the switch is off, when the switch is off, then this one the switch off means the power supply is cut off here. Then find diode is the forward bias and current flow from the here. Okay, I find this first one. When switch on, what happened? And diode reverse bias. Switch is on, then is a short circuit connected. Here open circuited. V the output or C L or on RL I input is the IL. Here the voltage VL. Voltage VL. First, in this circuit, you find the output voltage of any converter. So you should know about the voltage balance equation and current second balance equation. Should know, because of the any inductor circuit. If you take an inductor should charging and discharge between the period. If you get the supply and the inductor will get charged, it will not get discharge at any moment of time and time period. Then the inductor get saturated and circuit will not completed that. Such a same thing occurs in capacitor. In capacitor, the charge balance, when the charge is when the capacitor is once full charge, and disconnect the circuit also. Because then you should know about the flux balance and charge balance. And flux balance occurs in the inductor. Then you find the Bolt second equation in inductor, and current second balance equation we take in the capacitor. Then first of all we find VL. This circuit VL is equal to, you see about the V in is equal to IL in this period. V in is equal to IL in this period, then I take as the IL, and VL is equal to V in input voltage minus, to apply the KVL across, output minus IL into R on minus IL into RL. This is question number first. And I should know of the current dVc upon dt in the capacitor IC, also known as IC. IC is equal to IL minus I naught. Is I naught. I naught is equal to V naught by R. Question number 2. This one first, when the switch is on. Second one, when switch is off. Then what happened? Diode will be forward bias. See here. This one open circuited. This one C R R L L I L. This one diode VL. When the inductor get fully charged, then is released his energy. That time V naught. Then we reverse this polarity is act as the sources, not a sink. That time is reverse the polarity is the negative here and positive here. In that condition, negative terminal connected to the diode cathode, and VL should be greater than V naught, then also positive terminal here, positive voltage here, more than the cathode anode voltage. Then this time diode will forward bias and current flow like this. In this condition, current flow like this. Here you find VL. VL you applied, and VL find applied the same polarity where you take a reference polarity, not after that you change the polarity. Take a reference polarity. This is positive terminal of the voltage, output voltage, and this one the negative terminal here. This one means V naught minus IL into RL. Here R on is not in picture in the VL voltage, means inductor voltage, and IC is equal to same IL minus V naught by R. Third, fourth equation. After that you take voltage balance, voltage second balance, and current second balance equation. First I take volt second balance. In inductor voltage. Volt second, what says volt second? Volt second means charge and discharge voltage is 0. It means average voltage across the inductor is 0, and average current across the capacitor is 0. It means is VL on time dt plus VL off time on minus dt. Average of that divided by time, total time period is equal to 0. It says the volt second balance equation. I say also about the flux balance is in the VL in on time, you taken this V in minus V naught, like V in minus V naught minus IL into R on minus IL into RL into D plus VL in half time minus V naught minus IL 1 minus D minus V naught minus IL into RL. Only two things. Plus okay. Is equal to 0. Actually time we cancel out. Further to find this is the average. Average means IL into average current. V in minus V naught plus IL into R on minus IL into RL into D plus V naught plus IL into RL to D minus V naught minus IL into RL is equal to 0. Multiply by D, here also V in minus D V naught minus D IL into R on D IL into RL plus D V naught plus D IL into RL minus V naught minus IL into RL is equal to 0. D V naught cancel out. DRL I into RL I into RL, so cancel out. You find V in minus D IL into R on minus V naught minus IL into RL is equal to 0. Question number 5. Second one, bold second one, current second balance equation. D IC minus 1 minus D IC divide DT into 0. And the cancel out DIC IC is equal to same as IL minus V naught by R into D plus 1 minus D V naught by 1 minus IL minus V naught by R is equal to 0. Take this averages of that, you will find IL is equal to V naught by R. This is question number 6. Replace the IL here with the V naught by R from question 5. dV minus dV naught by R into R on minus dV naught V naught by R into RL minus V naught divided to 0. Simplify to find the V naught. V naught is equal to dV in divided by, if you solve this, 1 plus RL by R plus D R on by R. I in find in the when You have to find the V naught equation. V naught is equal to dV in divided by 1 plus RL by R plus dR on by R, and I naught is equal to V naught by R. So take for find the input current in, you say take the ideal condition, you know about the V naught is equal to dV in, then I in is equal to di naught in the ideal condition. If you take this in AR, then you find that efficiency is equal to P naught P in equal to dV in same equation into I naught divided by V into I into dI into I naught is the power. This one is the cancel out. Efficiency is equal to 1 upon 1 plus Rn by R plus d Rn by R. This is the efficiency of that converter. So question number 5th. Because this is the converter showing the figure has the non-ideality of the inductor RL, same as the voltage gain V naught will be in find in this converter. I will find. So this, if you see this converter, and this one is the boost converter, not ideal boost converter. Here the inductor resistance also mentioned here. Then this one, if you know about boost converter, V naught is equal to V in divided by 1 minus T in ideal condition. But here not the ideal, RL is mentioned here. And here is one thing is the switch resistance. On means on resistance is not given. It means switch is ideal here. Then same thing you find like a fourth question. First switch on, look here, when switch is on, then this circuit completed here, and this voltage appear across here. Ground is on, is diode connected to the ground, it means is off. This supply here, and this time consider supplied the voltage to the load. On diode in reverse bias. When is connected, short circuit. Diode is not in this. open circuited R plus minus V naught I naught. Diode is open circuited L RL Q switch V IL. The same apply the KVL here and here. Then we find VL. So VL is equal to V in minus IL into RL. And same as here, IC is equal to minus I naught is equal to minus V naught by R is equal to I naught is equal to V naught by R. Because the IC is difference to take there, then output current going like that. So IC is equal to minus I naught. So this is not means some, but IC is here. Second, and the switch is on, off. Then diode is a forward bias. How is forward bias? Guys, this is off. Then total voltage appear here. Then V in plus V in both appear here is the higher voltage, here lower voltage. So V not only, and this is the diode on. Switch open circuit. Here is VL. So VL, IL, RL, I naught, IC, V naught, R. It is VL. Here VL is equal to V in minus V naught minus IL into RL, and IC is equal to minus not IC is equal to IL, same current here, IL minus I naught, it means IL minus V naught by R. So applied here. Volt second balance case. Same as VL into dt plus VL into 1 minus dt divided by average voltage across the inductor is equal to 0. Then we find VL first condition, V in minus IL into RL, V in minus IL into RL into D plus dt cancel out. Second equation, V in minus V naught minus IL into RL into 1 minus t equal to 0. And V naught minus IL to RL. dV in minus DIL into RL plus V in minus V naught minus IL into RL minus dV in minus plus dV naught plus DIL into RL is equal to 0. DIL into RL cancel out, dV in also cancel out. V in minus V naught minus IL into RL. Because is here the average equation, then you can replace the IL is plus to the capital IL is the average IL. Second one, I should take after that you solve this question equation and you solve IL. Second one is IC into DT, oh sorry, current second balance equation. IC into dt plus IC into 1 minus dt divided by t is equal to average current of the inductor 0. First condition, IC is equal to minus V naught by R into D plus 1 minus D IL minus V naught by R. IL minus V naught by R is equal to 0. Minus V naught by R into D plus IL minus V naught by R minus D into IL plus D V naught by R is equal to 0. D V naught cancel out. IL 1 minus D is equal to V naught by R and IL is equal to V naught by I1 IL. Put IL in this equation and find V naught. V in is minus V naught minus IL is equal to V naught divided by R into 1 minus D is equal to into RL is equal to 0. V naught, actually I am missing one thing here. Sorry. V naught also here. Then V in minus 1 minus D into V naught minus IL into RL. This is the equation. Then V in minus 1 minus D V naught minus IL is equal to V naught by minus D into R, V naught by 1 minus D into R into RL is equal to 0. V in is equal to taken to 1 than 1 minus D plus RL divided by 1 minus D into R. Voltage gain, you have to find the voltage gain. Voltage gain means V naught divided by V in. That means V naught divided by V in is equal to 1 divided by 1 minus D common, then 1 plus RL divided by 1 minus D square into R. This is the voltage gain of the converter, lossy converter here. This is converted. I think T option. 1 minus D into 1 plus R over time 1 minus D whole square into R. Yes, okay. This is completed. All of you. Thank you to everyone. If you have any doubt, then give the comment in the comment section. I stop there. Thank you.